Okay, so hello everyone again. This is lecture 5 part 2 of wave optics. In the last lecture I was explaining to you what is interference of light and what did Thomas Young did to log the phases. In today's experiment or in today's lecture I will try to explain to you what was the mathematical formulation, small mathematical formulation only, and then further discussions were being held apart on this Thomas Young's experiment. So I am Samir Lavankar, let us begin. So introduction is done to you. Hume's principle about wavefront is being done, then refraction and the reflection laws were being proved using the Hume's principle and the wavefront principle. Then coherent and incoherent addition of waves are being done. We understood that the intensity for coherent was 4I0 or 2I0 and for incoherent it is always 0. And today I am explaining you the fifth point, that is interference of light waves and Thomas Young's experiment. So let us move on to the further discussions of interference of light only. So this was the initial wave in which two source light was being used and in which the phases can't be logged. So just let me explain here. So phases can't be logged here. And in this thing phases were logged. Okay, so let us move on to the further discussions now. So we were here in this mathematical formulation. Okay, so the positions of maximum and minimum intensities can be calculated by using the analysis given in the last section, where for an arbitrary point P, so this is the arbitrary point P we are talking about, on the line GG dash, so this is the line GG dash, to correspond to a maximum we must have. So for correspond to a maximum, that is we need to find out the bright fringe in the interference line. So how we will find out the bright fringe? For bright fringe, as the name suggests, the intensity has to be maximum. For the intensity to be maximum, the difference in the wavelength, that is the S2P minus S1P at the same point, should be a multiple of wavelength only. Hence it is written here that S2P minus S1P is equal to n lambda, where n can be either 0, 1, 2 or anything. Okay, so first of all we need to calculate this value. So how will we calculate this value? We use a simple formulation here. So first of all, S2P square minus S1P square will be equal to what? So I will try to explain you from here. So S2P, so S2P is this denotation. So if I try to explain this using Pythagoras theorem, let me take this triangle. So this is the distance S2P for you, and S2P is given as d square plus x plus d by 2. How this came? It is quite evident. This distance is given to you as capital D, and then this distance is given to you as x, and because the distance between S1 and S2 is d and it is located exactly in the center part, that is source S is exactly at the center part, that means this distance is d by 2. So capital D square plus x plus d by 2 whole square. So it is given here. So this is distance S2P for you. Similarly S1P will be what? So just let me change the diagram. So S1P will be denoted by this triangle. So this will be S1P for you. So here S1P will be, so this will be S1P, quite evident. S1, this distance will be capital D, and how to calculate this distance? This distance will be nothing but x minus d by 2, because this was the below was x plus d by 2, hence this will be x minus d by 2. Okay, so it is written here only, that is equal to d square plus x minus d by 2 whole square. Okay, so let me do the mathematical formulation here so that you can understand why it is coming like this. So d square plus x plus d by 2 whole square minus d square plus x minus d by 2 whole square. So here d square gets cancelled directly, it leaves us with x plus d by 2 whole square minus x minus d by 2 whole square. Now just opening the brackets, we get x square plus d square by 4 plus 2xd by 2 minus x square plus d square by 4 minus 2xd by 2. that leaves us with x square getting cancelled, d square by 4 getting cancelled, and this leaves us with only xd minus plus xd, and that leaves us with 2xd. Hence you will find out why it is equal to 2xd. Quite evident, direct simple use of a plus b whole square only. So finally what we get is s2p square minus s1p square is nothing but 2xd. So just removing this calculation. Okay, so 2xd is found out. So now also we know that a square minus b square is equal to a plus b into a minus b. Hence a square minus b square is calculated for us, that is equal to 2xd. s1p plus s2p will be written here, and a minus b will be nothing but the thing we need, that is s2p minus s1p. Hence to find out the s2p minus s1p, it will be nothing but equal to 2xd upon s1p plus s2p. Now our final calculation remains to find out this value of s2p plus s1p. So this is just just let me explain to you by writing here. So only two mathematical formulations were being used. First of all, we used a plus b square is equal to a square plus 2ab plus b square. Then next we used a minus b whole square, which is equal to a square minus 2ab plus b square. And third we used is a square minus b square is equal to a plus b into a minus b. Okay, so moving on now for s2p minus s1p equal to 2xd upon s2p plus s1p. Now please make sure the next point, that if x and d are very less than capital D. So as you can see from here, what does it try to explain you by x and d here? So these are the distances. Please look out to the below figure here. So this is that x distance, small x distance, and this is the small d distance. It is trying to explain to us that this small x and this small d are very smaller than this capital D. So this is a similar line which is being explained in the previous sections also, that is just let me explain. Yes, so he made two pinholes s1 and s2 very close to each other. So because they were very close to each other, that means the distances being explained here, that is small x and small d, should be very capital, should be very less than capital D. So this is one of the explanation. Why it is one of the explanation, I will try to explain you. So if x and d are very less than capital D, then negligible error will be introduced if s2p plus s1p is replaced by 2d. So what does it try to explain to you is, if this small distances, this small x and small d are very less than capital D, so then this s1p and s2p can be directly assumed to be straight lines only. If it is straight lines, then s1p can be denoted by capital D and this can be denoted by capital D again. So that means s1p and s2p can be written as 2d. So this is only the explanation, this is only the assumption why it is being put apart here. So if x and d are very less than capital D, then negligible error will be introduced if s2p plus s1p in the denominator is replaced by capital 2d. So for example, now an example is being used just to explain to you why was this assumption being used apart, because the difference or the answer difference which we get in the actual results is very minimal. So just to explain that, so for example, let small d be 0. So this is the diagram. So this is a diagram just to explain to you. Please remember where is small d. So this is the small d, that is the distance between the two sources s1 and s2. This is capital X, sorry, this is small x, which is the distance of the point P from the capital D is nothing but the distance of the screen from the sources, that is s1 and s2, or the pinholes s1 and s2. Okay. So for example, for d is equal to 0.1 centimeter, let capital D be 100 centimeter. These are the actual experiment values only. These are not vague values, they are actual experiment values. Let OP be 1 centimeter. What does OP explain to you? This is the OP distance. OP distance is nothing but x. So x is given to you as 1 centimeter. Just let me write here, x is given to you as 1 centimeter. Okay, so which corresponds to typical values for an interference experiment using light waves. So now we have, so we try to first of all calculate S2P and S1P using the exact mathematical formulation of Pythagoras theorem. So what we did was, to find out S1P, we added d square plus x minus d whole square, x minus d by 2 whole square we did for this, and then we did the under root. Similarly, to find out the value of S2P, we did again the Pythagoras theorem for this triangle. We did the Pythagoras theorem for this triangle here. Okay, so on a final calculation, what we found out that the S2P plus S1P was equal to 200.01 centimeters. And if we took the assumption that let us explain that S1P plus S2P. If I took the assumption that S1P plus S1P is equal to 2D, then 2D gives us 2 into 100, which is equal to 200 centimeter. That means only a 0.01 centimeter difference was being observed, because the negligible change, because this is very minute difference, that is why this assumption is being used. What is the assumption being used? That is small x and small d are very less than capital D. Okay, thus if we replace S2P and S1P by capital 2D, the error involved is about 0.005%. So because the error involved is very less, that means it will not affect our actual simulations or calculations involving white fringe, dark fringes and bright fringes. Hence we can directly use S2P and S1P is equal to 2D. So now in this approximation, the above equation becomes, so this is the final important formula, that is S2P minus S1P is equal to xd upon capital D. So how does we find it out? In the last analysis, we found out that S2P minus S1P was nothing but 2xd upon S2P plus S1P. We found out that S2P plus S1P is nothing but 2 capital D. So it is 2 capital D, just removing 2 capital D we get x small d by capital D. So hence this is one of the formula, which is important formula for the interference of light rays, that is the difference between S2P and S1P is approximately equal to small x small d upon capital D. Hence to conclude this, so just me write, so these all things are explained to you. Now hence we will have constructive interference resulting in a bright region when, so when it will happen, when this is approximately equal to n lambda. Hence we to just need this point, we just need this x value, that is the distance from the 0 point to that point P where it is happening. If we find out that point distance x value, then we can find out where bright fringe is happening and where dark fringes are happening. Hence small x is nothing but, so just simple mathematical redistribution gives us x is equal to n lambda capital D by small d. So please remember this formula, very important formula from the exam point of view. So hence we will have a constructive interference resulting in a bright region when x is equal to xn is equal to n lambda capital D by small d, where n can be 0 plus minus 1 plus minus 2. So just to explain to you the complete statement again, first of all please explain, please let me, so this is the only and only explanation when we need to find out the bright fringe. For the bright fringe, S2P minus S1P should be equal to n lambda. If S2P minus S1P should be equal to n lambda, then after mathematical formulation we find it out that that distance x should be equal to n lambda capital D by small d. So this is the final explanation for interference of maximum intensity, and then let us move on to dark region. So quite evident, for a dark region what the change would be, that S2P minus S1P should be equal to n plus 1 by 2 lambda. Otherwise everything else would be same, so only there is a change in the value of this small n. If we take it as a constant k, then it is only a change in k. K was n before and it is n plus 1 by 2 now. So simple mathematical calculation will give us x is equal to n plus 1 by 2, again n plus 1 by 2 into lambda into capital D by small d, where n can be either 0, 1, 2 or 0 plus minus 1 plus minus 2 etc. So similarly on the other hand, we will have a dark region near x is equal to xn, which is equal to n plus 1 by 2 lambda capital D by small d, and hence a dark fringe is formed. So just to explain to you, here a bright fringe is formed. Here a bright fringe is formed and here a dark fringe is formed. Here a dark fringe is formed. So thus dark and bright bands appear on the screen as shown in the figure. So this is the screen being explained to you. I will try to explain you everything which is coming here. So this is a screen, typical screen. So what happens is, you can see clearly that, just look over this. So this diagram is quite clear. This does not have curvy lines also. So first, for simple mathematical calculation, you just try to explain. I will try to explain. First of all, you can see that at point 0, what is happening is, I will try to explain you mathematically only. So at time, as S2P minus S1P for maximum brightness should be equal to n lambda. If I put the value of n as 0, that means S2P minus S1P should be 0. Hence, the value of x, or the value at x equal to 0, should not have a dark fringe, it should have a bright fringe. So it is quite evident from the diagram also. As you can see, at x equal to 0, you can find a white fringe here. Then subsequently you will find dark fringe, white fringe, dark fringe, white fringe. So what does it say to you? Either you would go towards right or you to go towards left. It is the complete screen only, there is no change in that, and hence you can find out dark fringe and bright fringe. So just I need to explain to you that so it is quite evident from the mathematical calculations also that at x equal to 0, you will get a bright fringe, and then subsequently you will get dark fringes, white fringes, dark fringes, white fringes. Okay, so let us move on again. So thus dark and bands appear on the screen as shown in the figure. Such bands are called fringes. Such bands are called as fringes. So these are nothing but called as fringes. I explained to you before only what are fringes here. Fringes are these straight lines only. So above equations show that dark and bright fringes are equally spaced. Quite evident, as you can see on the diagram also, it is equally spaced. It is not like the white fringe is having 1 centimeter distance, and let us suppose it won't have 1 centimeter distance also. I am just hypothetically speaking that dark fringes is having 2 centimeter distance and white fringe is having 1 centimeter distance. It is always same. It is always symmetrical. It is always symmetrical. The diagram is almost this only. Sometimes it is curvy. Why it is curvy, I will try to explain if the thing persists. But for now, for the simple mathematical calculation, it is always like this only. That is, it is always equally spaced, and always at x equal to 0, it is a white fringe. Okay. So above equations show that dark and bright fringes are equally spaced, and the distance between two consecutive bright and dark fringes is given by. So to find out the value of bright and dark fringes, I will try to explain to you using actual analysis only. So first of all, what we find it out, that let us say at some x n lambda capital D by small d is the distance. If we find it out using x n plus 1, then x n plus 1 is equal to n plus 1 capital D by lambda capital D by small d. Now if we need to find out this fringe width is nothing but the difference or the distance between two subsequent white fringes or dark fringes. So it is equal to just n plus 1 lambda capital D by small d minus n lambda capital D by small d, that gives us lambda capital D by small d. Similarly, to find it out for dark fringes, it will be simply again writing it beta only. So beta is equal to n plus 1 by 2 lambda capital D by small d minus n plus 3 by 2 lambda capital D by small d. I just this should be 3 here and this should be 1 here, because it is x n plus 1. Hence we will get again lambda capital D by small d. Hence let me conclude the lecture here only. So finally, what we found it out in this, what was the conclusion of this part? In this part, I tried to explain to you how what is the distance from the exact screen point O to calculate the value of distance for which we will get the maximum intensity and the minimum intensity. So for maximum intensity is n lambda capital D by small d, and for minimum intensity is n plus 1 by 2 lambda capital D by small d. Finally, we found out another formulation, that is fringe width. Fringe width nothing but the consecutive distance between two consecutive bright fringes and dark fringes, and on mathematical calculation also we find it out it is same, and it is equal to lambda capital D by small d. So today I will conclude it here only. In the further analysis we will further understand some of the discussions which is important for Thomas Young's experiment only. So for this analysis, thank you.